Hello students, welcome to the lecture number 29 of Petrochemical Technology. We have the new topic, that is alkylation. So alkylation is very important unit into the refinery that will be resulting to obtain the product of high octane gasoline component, that is known as alkylates. So let's begin with the alkylation. Alkylation is a chemical process used in petroleum refining industry to produce high octane gasoline component known as alkylates. It involves the combination of smaller high molecular weight hydrocarbons. So we are using smaller or low molecular weight hydrocarbons, usually olefins, with isobutane to form the larger branch chain of the hydrocarbon. So we are using olefins to form larger chain of hydrocarbon into the alkylation unit. So these branch chain hydrocarbon possess excellent anti-knocking property. So these big branch chain hydrocarbon that comes from the alkylation unit, that is the final product, this is having the excellent anti-knocking property, and these are valuable component for enhancing the gasoline octane rating. So once the high octane number gasoline we obtain from the alkylation unit, this has very less uh, the anti-knocking properties into the engine, and the performance of engine is increased. So the key points about the alkylation processes are feedstock. So now first we will talk about the feedstock. What kind of feedstock is required in alkylation unit? So the primary feedstock for alkylation are typically light olefins. We have low molecular weight olefins, that is light olefins, such as propylene or butylene. So propylene or butylene, these are the olefins having low molecular weight or light olefins. So these are the main feedstock into the alkylation unit, and this is obtained from various refining processes like flute catalytic cracking or catalytic reforming, and isobutane and isomer of the butane. So these are the basically main feedstock that is obtained from catalytic cracking or flute catalytic cracking or reforming. Now we will talk about the catalyst. Which catalyst is required into the alkylation reaction? So sulfuric acid and hydrofluoric acid, these are the two type of catalyst that is mainly used into the alkylation unit. So sulfuric acid and hydrofluoric acid are the two commonly used in catalyst into the alkylation. So these catalysts facilitate the reaction by promoting the combination of olefin with isobutane, leading to the formation of high octane alkylate compound. So olefin, small chain olefins is low molecular weight olefins like propylene or butylene. These are combined into the uh, alkylation unit in the presence of catalyst like sulfuric acid or hydrofluoric acid, and that is leading to the formation of the high octane alkylate compounds. Now the next step is reaction condition. What kind of reaction conditions will be into the alkylation unit? So alkylation reactions are conducted at low temperature. This does not require very high temperature. So this reaction occurs at very low temperature and moderate pressure. The pressure is also moderate to prevent unwanted side reactions, cracking reactions basically, because we are combining the low molecular weight uh, low molecular weight olefins. So the reaction occurs typically at temperature between 0 to 50 degrees centigrade or 32 to 122 degree Fahrenheit, very low temperature, and pressure around 200 to 400 psi. This is also very low pressure. Reaction chemistry. Now talking about the chemistry of the reaction, in the alkylation process, the acid catalyst facilitate the transfer of hydrocarbon molecule from an olefin to an isobutane molecule. So there is a transfer of hydrogen molecule into the reactor, and this makes the isobutane molecules and resulting in the into the formation of larger branch hydrocarbon. So these the hydrogen molecule joins the structure of the two different olefins, and they make the larger branch chain of the hydrocarbon, and the resulting alkylate compound have superior anti-knock property. That alkylate we got after the combination into the alkylation unit, the two olefins, these are having a superior anti-knock property, which enhances the octane rating of gasoline when blended. When we are blending this gasoline, it is improving its octane rating. Now, the what kind of product we get from alkylation unit, we will come to know into this step. The product, the primary product of alkylation is alkylate. It is called alkylate, a high octane blending component used to improve the quality of gasoline. Alkylate has excellent anti-knocking property, low vapor pressure and low sulfur content, making it valuable for blending into gasoline. So this alkylate is blended into the gasoline to enhance its octane rating and improve its combustion characteristics. And also, alkylation plays a significant role in producing high quality gasoline with improved combustion performance, and it allows refiner to increase the octane level of gasoline without relying heavily on aromatics or other component that may contribute to air pollution. And moreover, alkylate is valued for its clean burning characteristic and its ability to enhance the efficiency of combustion into the engine in modern engine while meeting environmental regulations. Now into the next slide we will show you the alkylation unit picture into the refinery. You see there is a olefin alkanes, that is propane and butane. This is going to the reactor. Into the reactor there is a acid catalyst are present. So now these two component are joining, propane, and this is acid settler. The acid that is present into the reactor, this reacts and it is collected here, and further it is going for caustic wash. The product is going for a caustic wash, and this is your fractionator de-isobutanizer. This is called the de-isobutanizer, that is a fractionator where you first top product you collect the isobutane, and here you collect the butane, and at the bottom product you collect the dimethyl pentane and trimethyl pentane. That's all overall the explanation of the alkylation unit into the refinery. For any question you can write me message or you can call me. uh, the next topic will be continued in lecture number 30. Thank you.